Nice, perfect. So hello and welcome to my call, to my presentation about messaging calls and videos in Kubernetes, the Kamailio and RTPengine way. My name is Řehořek and I'll guide you through this presentation. So something for the agenda. So firstly, we're going to talk about the introduction. Who am I? What's the company? About Kamailio project, telco transformation, and then in the next section, we're going to talk about the journey to cloud native voice. Why is it made? How architecture, voice simplified view. Then in the next section, we're going to talk about open source stack for real-time voice. Nice, sounds good. What is going to be the main focus? Finding the right tools for this, setting it up, Kubernetes objects overview, what you need for it, additional work, and tools that you might need. In the next section, we are going to show you what did we achieve. That following up, it's going to be demo of our workflow that we have prepared for you. We're going to have SIM graph for call flow and then some challenges. Some project without challenges, I think it doesn't exist. And you might see some challenges that we faced during that. And lastly, we're going to have a conclusion. So let's start with the introduction. So you might see me on the picture. I usually attend these events. My name is Řehořek. As I said in the beginning, I work for Deutsche Telekom, as you might see the logo in the bottom. You might know it from T-Mobile Czech or T-Mobile Slovak or T-Mobile Poland and much more, the subsidiaries. I'm a DevOps engineer working under DT for almost 3 years. I've been included in projects as 5G, the project that I'm going to show you, CPaaS, and automation. And for those who don't know Deutsche Telekom, it's a telecommunication company made for producing us and creating us voice traffic, SMS, data, 5G, IoT, and our own cloud, public cloud called OTC. That's something for the introduction. And a bit of a nostalgia for me. I was here 2 years ago on my first Cloud Native Prague event. You might see me on the picture there. It was the 6th, and it's the same place, and I'm really happy that I can present you with something of our own. So, for the introduction, the Kamailio project, maybe you have heard about it. It's our contribution to the CNCF community. Kamailio actually is just a way on how to work with API, standardization, so that developers can easily develop, test, and use the APIs. You can see the points that it has and provides. And we can see on the picture from the keynote on the KubeCon 2025 in London, that was mentioned as well with some other projects that are dedicated to Linux Foundation. So last part of the introduction is the evolution of telco. And as you might see, another picture from the keynote in London. And as you might see that the voice has naturally developed, new generations came, and we're going to focus on the transition from 4G, 4th generation, to 5G. And if you don't see it, I will tell you that the 4G is the step where there was virtualization and disaggregation to virtual network functions. And we are currently looking into the next step, which is the 5G, and that's containerization. And also some appropriated tools used, I don't know if you can see, Kserve for AI or some IoT devices and much more. So this was a thing mentioned from the Vodafone perspective, and I think it's quite the same for other telcos. So now our journey to cloud native voice. So the question, why did we want to do it in the first place? So you can see maybe the $ that we wanted to have cost savings. And it's connected with the sustainability and scaling, right? Because if you can have a platform that can scale down and don't use resources such as energy or electricity and water and stuff like that, it's healthier for the environment, right? So that's a good thing for us. The third point is the scalability. As I mentioned, usually you don't call anyone during nighttime. Who calls someone at 1 a.m.? Probably no one, right? So why do we have to pay for infrastructure that's running this in the cloud, right? Why don't we just, scale down? or scale up if there's a football event or Mother's Day or some significant day, right? And the fourth one is knowledge, because this is evolving, this is a new era, new generation. So we want to gather some knowledge in this era, right? So that was the fourth point, why did we start this journey? And also, you might see the sentence that Nokia is already looking to cloudify the voice, and that we know that the voice race has begun in this transition. So for you who don't really understand what is it about, what's actually deployed, I prepared for you a simple presentation of the simplified voice architecture on the diagram. And as you might see, that there are two actors, operator A on the left side, operator B on the right side, and that we have some network components such as the voice load balancers, the SSC, which is signaling session controller, and MSC, which is media session controller, I think. And I will guide you through a work process or how it actually works. So an operator creates a SIP invite, which is a protocol for signalization, and it gets to the voice load balancer. After that, it sends this request to one of the, let's call it SBC, which is like a group for these two network components. And this is session border controller, known as SBC. So it finds one trunk or SBC that it wants to connect to. Then it goes to the SSC for signaling, so this request comes there, and it will initiate communication with the MSC, which is a media relay. It does the heavy lifting on the media, transcodings, and much more. And this SSC is just part of the flow for the signaling. So we have this part covered. It tries to find a voice load balancer that is closest to the operator B to send this request. And after this signaling is accepted and connected, then the RTP streams are protocols used for media. And if everything goes well, then they can hear each other. So now we know the simplified architecture. Now we need to find the right tools to solve this project problem, this new generation, right? It would be good that it could do the heavy lifting. We wouldn't need to come with it up ourselves. We could just use some open source, right? So let's see what we really want to put in the cloud, and that's the SBC, because it does the heavy lifting for us. So our team had few people, but big plans, right? It's quite difficult to put this into cloud, as major companies are using the virtualized network functions. We called it a CEVO, which is abbreviation for containerized evolution of voice for us. And we had two main objectives: to create a small voice platform that could be in the cloud and also use open source technologies. And also the second part was gaining experience in running voice applications in Kubernetes. So we know now what we want. Let's find the right tools, right? Read some research, look into presentations, look into academic papers, and so we did. And we have another 3 questions for that, right? So in the picture, if you remember, we were looking for something for signaling, media, and also it would be nice to monitor, right? If you have multiple calls, hundreds, thousands, millions, right? You need to see what's wrong, or if someone has a jitter or it doesn't work, right? So you need to look for these tools to implement it. And for the signaling, we had multiple contenders, one of them being Kamailio, as maybe you heard from the title of the presentation, Asterisk. There's also FreeSwitch and multiple other open source tools that you can use and is at your disposal. The main, I think, key difference between Kamailio and Asterisk is that Kamailio is just for signaling. It's high performant. It can handle millions of calls just by one instance. So it's really performant. It's also open source, right? We are talking about open source. And I think the benefits were also that there are modules that are extensible, that you can view the documentation, use what you want, what you don't want. And that, in comparison to Asterisk, it's also the same, but it includes also media. So it's not isolated, the signaling and media part. It's just one thing in bundle. It works nice, but it's compute heavy. and you want something that's not really connected to each other, so that you can scale maybe one part, not really scaling the signaling if you don't need it, right? So this was our decision to pick Kamailio here, and then the second thing that we were looking for is the media relay, media proxy, or the media transcodings, right? So there were two possible ways, and we were mainly looking for something that's integratable with Kamailio. And as you might see on it being highlighted, both of them integrates with Kamailio. And for us, that we used something in production with also RTPengine, we were sure to use the solution instead of the RTP proxy. They're quite the same. Configuration is also similar, not even maybe the same. And they have also features that you can read on, but for us, it would do the same job. So we opted for RTPengine here. And also something for the monitoring, right, would be nice. And we figured out that there was one tool called Homer. You can see the logo on the right side, and it provided us an open source monitoring solution, integratable and made and tailored, to be honest, to Kamailio. So that was nice, right? You could analyze the packets, you could see the traces easily, and you could just have a monitoring tool at your disposal. Nice. And I wanted to mention that there are two versions. One is the old one that has a different architecture. As you can see, the tech stack over there, and essentially is like a web GUI that you can use in your monitoring stack. And the new one has something new. It's built on Grafana, so you have dashboards there, and much more over in this solution is more adaptable. You can change, you can create your own dashboards, right? Instead of in the old version, you can't really do that. And I can show you, this is how the old version looks like. So you have just normal UI. On the left, you have filter. On the right one, you can see the individual messages from the SIP. So that's that. And also the new version, I'm sorry for the quality, but this was from the original documentation. You can see the Grafana, and that it has some pre-built dashboards that you can also filter and see the voice calls, or call flows, sorry. And with that, I can see that you can also make some, also some, you can build anything you want there, to be honest. So now we have the tools, right? So it would be nice to see, and put it into the architecture picture. So one more step deeper, and we have the Kamailio substituting the signaling module. We have the RTPengine to substitute our media. And also we have Homer in addition. And you might also see MariaDB connected to Kamailio, because Kamailio has the possibility to use external database. So with that, we can move one step, inside, and we can view the. I kind of broke it. Sorry. Now you can see environment that is called air-gapped environment, because it can't use internet, or it can't be ingress or egress. Nothing there. So you need to use specialized proxies and stuff. So I present you with the simplified view of the architecture plus the actors and the requests. So I would firstly start with the infrastructure. As you can see, I already told you about the environment. You have Kubernetes cluster there, and also you have an infrastructure as a code environment where we deployed some virtual machines. So I would talk about the first flow, and as you might know, GitOps principle and approach. You have a developer that pushes a code, and Argo CD pulls the changes and applies it to the cluster. Then we have the second flow, which is the people under the diagram, and they're called Martin and Ronnie, and they want to make a call, right? So firstly, I send a SIP request. I would like to call Ronnie to the load balancer, and after that, it does its magic and goes to the cluster, finds the correct pod, and then sends a SIP request back to Ronnie. I want to call you, right? And what needs to be done after it accepts, so this bidirectional flow, he will accept, and we can start sending RTP traffic through the RTP request, if you can see them. So that's the second flow, and in the third flow, we can see the two virtual machines being dummy operator 1 and dummy operator 2, what you would see in the real traffic. And dummy operator 1 would do the same flow, calling the SIP request to the load balancer, finding the right pod, then contacting dummy operator 2, and then establishing RTP streams. So that's the main workflows that you might see. I know that we put some logos there, but there's much to it. Just a simplified view of the architecture. And we also seen on the internet that there's some tools or projects that you can learn from, one being full VoIP service on Kubernetes. We looked into this and have a similar approach to this platform. So if you want to look and really see, how could you do it, there's a deployable Helm chart, I think, available at the GitHub mentioned over there. So we probably know what we need to do, but how to set it up, right? So documentation is your friend, or is it? Because there are multiple versions of Kamailio. The documentation is not so up to date with these versions, right? Like you can have a major documentation for one version, but not for the other. And if you see some blog post about this version, and you can see that it's not, working on your version, right? So it's a bit of a documentation hell, but if you dive into the documentation, you can definitely make it up. And how are the Helm charts, right? We want to deploy it to Kubernetes, so it should be somewhere, right? During the research, I found out that some Helm charts were deleted or put into private, so I can then guide you how can you find some, good Helm charts or some star that you can, work with. So for the RTP engine, there's a Fonoster project that has the RTP engine and also Kubernetes objects and Helm chart. It's public, you can view it, you can find it on the site, on GitHub. And there's another project called Jambons, and there you can see a lot of tools, but one of them being RTP engine and Kamailio. So you can definitely see some examples of Helm charts and Kubernetes objects that you can, refer to. So here is our minimal setup, what you need for the Helm chart. It's structured into three, let's say, types of Helm charts. One is Kamailio, one is database, and one is RTP engine. So a bit kind of standard, I guess, deployment, but I can guide you through the Kubernetes objects. So config map, easy for configuring the Kamailio and the instances, right? Deployment, again, classic, how you're going to deploy the instances, right? Service, headless service is interesting because you need to have the IPs of the Kamailio instances for them to be able to synchronize. And classic load balancer and secrets for secrets management in the Kamailio configs. The next one is database, a bit standard. I think I don't need to really go over that. And the third point is quite interesting because you have RTP engine. And the standard way, and also in the academic paper, we saw that they are using daemon set. And if I'm not mistaken, you can use one pod there in individual node, there's one pod running, right? But you don't really want that because you want to scale, right? You don't want one pod handling 150 calls. You want millions, right? So in this way, we opted for deployment, and it has its difficulties to maintain it, to provide the configs right, and to update it. But again, similar stuff as in Kamailio. So I mentioned the configuration, right? It's a bit tricky, because the main configuration lies in 2 or more files, one of them being Kamailio CFG, and it contains around 1,100 lines on the main branch. We had around 1,600, but definitely we had something more included that wasn't necessary, but for our documentation purposes. And it's something like a long list, really like a good old config file. And you can import the other files if you want to. It's extensible by the imports. And it can be a bit difficult to hard to read, as you might see, in the following slides. So here I just took, I think you might understand a bit of the code. You have routes, which are something like functions. You have returns and other keywords. I don't know, possibly you might know that xlog is just logging it in the console. But it's not that difficult, I guess, to write. But there are certain variables that you need to just look into the documentation, know what they do, what are the parameters, stuff like that. And another thing that we needed to do extra was the synchronization module, or like an operator that was talking to individual pods, seeing if they have the configuration ready, if everything works. So that was our additional work that we needed to do. And we found out that there was another solution, quite nice, as I mentioned, with the console on the open source project that you might view, that they were handling these network, I guess, configuration things with console. And additional tools that you might want, and one of them being KubeShark, but as I mentioned, it was air-gapped environment. It was not really usable with the permission it had, so we couldn't use it. But it would substitute TCP dumps and Wireshark, troubleshooting and analysis, what's going wrong. And another great tool is SNGrep, which you might see in the bottom right, and it essentially shows you the call flow with the parties, the call lags, the SIP requests, also the data as well. Another great tool is SIP-P, used for testing. So if you want to do traffic of 100 calls, you might need to opt for SIP-P rather than just doing it on your own manually. So a bit of an automation. So now comes the good part, right? What did we achieve? So we deployed it on our private infrastructure. We created successful calls with SIP-P, so multiple hundreds of calls. We used SIP agents, something like Linphone or Zoiper. Essentially, it's like an app that you can use to create SIP calls with. And we created calls, video calls, and messages. I know it might sound like WebRTC, but we were just extending the scope of what it can actually do, but we were focusing mainly on the calls. And we were able to scale to XPOD. So the scaling kind of worked. And we also learned about what we wanted, and that's the voice ecosystem in the cloud, right, in the Kubernetes. But also the benefits and challenges that came along the way. So now I would show you a video that we prepared for you with my colleague Ronnie. It's going to show you a simple use case that we thought of showing you what it actually does. So I think we can play the video, I think.
Teams are not working. WebEx is now gone. Well, what should I do? Oh wait, I have Siebel. Let me call Ronnie.
Oh, Martin's calling.
Let's do a video. Oh, hey Ronnie.
Hey.
Wanna meet for lunch at the INMC in the canteen?
No, I don't like the canteen in Frankfurt. How about the burgers downstairs?
Sure. Let me be there in 5 minutes. See you there. Bye.
See you. Bye-bye.
So the joke was there that there's no canteen. It doesn't exist, but I know that you might know about that. But this was such a demo that showed us that it's actually feasible to run it on a private infrastructure and with the components that we had and the minimal setup. So I can show you how, again, the call flow looked like. So on the bottom left, there's me, Martin, calling Ronnie, going through the load balancer, finding suitable Kamailio, finding the right RTP engine that has the ports available, and then contacting Ronnie. Hey, I want to call you through the Kamailio, and if he accepts, then the RTP streams can flow through us, and we can send data. And also here you can see the SNGrep. So in details, you can see the call lags, Martin, Kamailio, and Ronnie. The Kamailio is in the middle, and I'm sending a invite request to Ronnie. It goes there, it's trying, ringing, and then it comes to me back. Then I respond with OK request, and that we are sending data, and at the end we have bye. So we just canceled the call, and this was essentially what you just saw on the video, but just behind the scenes. I needed to remove certain information from there for security reasons. Sorry for that. So this is nice, right? It looks like it works, but there were the challenges. So first of them being the hardware, actually. Because we tried so hard to set it up correctly. We wanted to have the real-time experience, but it seemed that it's a bit difficult to set it up. The documentation for the previous version was quite okay, but again, you need experts for this kind of tool, to be able to deploy it. So it was a bit difficult. Not much documentation was made for the new version, which we were kind of hoping for. The new stack, it looked kind of nice. You could put it in Grafana, right, like many of you do. But again, the documentation was not really there, but it looks promising. Like, we really saw like what it can do. We played with it, but again, we could not really deploy it well so that it would be able to be used. And by our observation, again, I would definitely recommend you maybe waiting and focusing on the new version, which is getting updates almost monthly or by 2 months. So definitely something that you can look into. Another big challenge was the config, because it's endless almost sometimes, and it's difficult to follow, right? You have a big config, and what you can do, it's you can build your image, then you can run it, but then you try to do something and it fails, and you can repeat that, or you can just somehow import the config, restart it, and do your magic, which we did. But again, finding out what parameter is wrong, looking through the documentation, it was cumbersome. It was tiring and frustrating. And we would suggest you just using automated tests or some setup automation that can help you, with that. Another challenge that was mentioned a bit is the synchronization of the nodes. Particularly, we meant Node as the Kamailio and RTP engines. You might see, again, lower resolution on the top right, I'm sorry, it's from the academic paper, that they were thinking of having some kind of a leader, then figuring out what pod is available, is a bit emptier, so that there would be less failover and stuff like that, redundancy, that's nice, but they were using the daemon set. So this was not really handled in our particular case. Definitely there are options with another caches, some redirections. So definitely there are options to solve that, but it's not natively covered. And I think there is another security challenge, because you might have seen, if you were looking right, that the RTP engine should go through the deployment, right, from the pod, right? And that's connected to a node, right? So you would need to expose node interface in order to communicate with that. And again, this is a bit solvable, but needs additional steps for you to solve. So it's not as straightforward as you might think. And another challenge was the scaling. As I said, it was to X numbers, so it wasn't nothing too high, but also nothing too small. But as you can see that Kamailio can handle millions of calls, as I mentioned, in the benefits, but the RTP needs a lot of resources in order to do the media translations. On the top right, on the bottom right, you may see that there was a peak at 150 calls per RTP engine, and then the quality was way worse. So we figured out that after we can use an RTP engine for 150 calls, and after that we need to find a different RTP engine. Another thing that's quite a challenge here is that for a call to happen, you need 2 ports open. And I think I will just follow up on that in the next slide. But I want to mention also the configuration management is the key. As you saw, that you needed to have like an operator handling these config maps in order for the Kamailios and RTP engines to be synced. And quite not really nice feature is that you can do a restart in runtime, but they say in milliseconds, but what if it goes to seconds, right? You can maybe cause some outage or something. So again, the configurational management is a bit hard. And the challenge, another that was presented, was the ports, right? So by native Kubernetes deployment or setup has some node port limitations, right? And you can see on the picture that you have somewhat of 2,700 free, right? But the call needs 2, so technically you wouldn't be able to scale to millions of calls per your setup. So. And you might see that the RTP engine needs annually 1,024 to 65K, which is understandable because these deployments are not made for Kubernetes natively. It was made for virtual machines and or containers on Docker just for experimental reasons. So another a solution has been brought to us, and that's using Multus. Maybe if you have heard about it, but it's a CNI that allows you to create more network interfaces. So technically, you could use this strategy to have more ports for your setup. But if you opt for this, then you need to figure out something about network management, because you do certain features that Kubernetes provides you by default on the network side, such as service discovery, and I think you will lose cluster IPs and much more. So you need to handle that if you want to use Multus. But that's about it for the challenges. Here is the conclusion. And I wanted to mention that the telco environment is evolving and moving to being cloud native, and we want to be part of that. When it comes to Kamailio and RTP engines, not all is really easy. You have the configuration, you have the documentation, you have the test, and you need to do so much more to it being operable. But if you know what pain points are when you're running voice applications or stateful workloads like that in the cloud, you need to be thinking primarily of the infrastructure and planning on how it actually is going to work, what you need, what are your requirements, before you try some solutions there is. And the other 2 points are that open source tools actually exist for telecommunications companies and that they are using them. And it's nice to see that we are also part of that. And last point that I want to mention is that creating a voice platform can be hard and challenging, but after the pain, it's definitely doable and achievable, and you can create it on your own. And I think here is going to be the part for questions and answers. I don't know if I will see the Slido or someone's going to come to me.
Welcome.
All right, thank you so much.
So first question, how is difficult exposed telecom services in Kubernetes when it does not even allow to specify port ranges for services? Is there any standard solution?
For specifying ports for telecommunication workload or in Kubernetes? Was a question like that?
Yep.
That was my question. My question was, is there any specific? Yeah, thanks. That was my question. I asked if there are any common solution which telecom companies use to expose the RTP services in Kubernetes.
I know that there's not like a standard way, because I think this is widely used in the operator space. So technically, like, you have security concepts when it comes to like real production, but if you do like like this SBC, yeah, it's quite sometimes insecure, and the academic paper talks about it. Like, there are solutions 100%. I couldn't really explain it here over now, but like definitely you can. I will show the references, and you can also like use it up. But yeah, it's like one of the major security challenge that you need to solve, to secure your deployment or usage. But there are different types of solutions. So we presented only what you can do like that, but there are definitely, I think, like other solutions that take advantage of it being secure, or there's some security on top of it to protect it, right? So you can use some public or private, or you can use subnetting, right? Or in network you can definitely secure it in a way that it's possible to use this solution. Yeah, definitely. But we weren't really focusing on this because we had it on private infrastructure, so we had everything secure, so we didn't really need to think that hard in terms of security because we were running it privately, so yeah. Thank you, though.
Okay, another question. What are the main challenges with the gateway session routing for real-time voice?
Oh yeah, that's a good question. It's so difficult. Yeah, I know that we were thinking of like sticky sessions and stuff like that, to have like sessions. We know that the load balancers are smart, so that you can put your session ID and stuff like that and get routed. And as well, Kamailio provides a way on how you can do these sessions by geolocation. So I don't know, if I send a request over here, it will have the geo coordinates, and it will know where to route it to. So it has its possible ways on solving this. Yeah, definitely sessions are part of that. And you can do it with a load balancer, or you can do like Kamailio to load balance it for you. So there are multiple options on how you can do that.
Okay, another nice question.
I know that some of my colleagues are watching and providing some questions.
So in addition to what you already answered, do you use any special gateway solution, or Kamailio is providing it?
Yeah, so I think we were using the load balancer that was in our private infrastructure, so we didn't really need to think about it. But Kamailio can provide that. Definitely can work as a proxy or a load balancer. It has more uses, and I think there are also different types of load balancers that you can use with the voice to distribute it with your your parameters, or you can do some inspection and you know where to send it to.
Okay.
So next question. The hard
Shoot
one.
it.
Please, how many calls can you handle by a single instance? Did you implement automatic scaling? Any feedback from the production?
I think this one is from Tushar. But so, yeah, we were able to do multiple calls, definitely. We were able to scale, I think like we had it at I don't know, 4 Kamailios or something like that, because like, yeah, we don't need to really scale that. So we had it on lower end, but the RTP engines we were testing, like, if you have 2 plus or 4, to see if it works or not. And yeah, so we were able to use the testing, and that was quite nice. It was showing good results. But whenever we did some changes in the load balancer, it behaved quite poorly, and some of the calls were not working. So it was a bit difficult. But yeah, as I mentioned, Kamailio can handle millions of calls, and RTP engines, again, like around 150. But you don't want to get there, right? You want to do like 120, yeah, something like that. And in terms of cost, was there something like that, or?
It's already disappeared. So
Oh shit! Okay.
maybe Pavel, if you can
No, I know who
revert it. So.
I know who it was, though. I can tell him.
So the next one, you mentioned the cluster was air-gapped.
Yes.
Can you elaborate it more?
Yeah. So, in terms of the air-gapped environment, we have this on our private cloud. So we have huge restrictions on that. Like if you have customer data, it depends on what. So you have different grades or tiers that can be exposed or not. And during this project, we had everything running on private infrastructure. So you had to have some certain workflow that you can work with that. And the internet was not present, so we needed to handle it via mirroring repos, having private artifactory. Every image was scanned, and some security concepts over there. So it couldn't communicate with the internet or download stuff or be exposed to the internet. So it was air-gapped. We call it like that. Yeah, just there was like a thin line, I guess.
Okay, back to the previous question. It was how many calls can you handle by a single instance? Did you implement automatic scaling? Any feedback from the production?
Yeah, good point. Yeah, automatic scaling, we weren't able to achieve some HBA or some scaling based on the data. Again, it was just our limitations because we had the native Kubernetes deployment, so standard, less ports, so we couldn't really scale to big numbers, with the metrics and stuff if we implemented that. So we weren't able to because, yeah, of the architecture that we have now. We are, focusing on the multis. Yeah, we want to, see how can we do it with multis and to extend the port range. And to the production ready, yeah, that was a good question because we had the same presentation to our management, and that was the first question actually. So, but we think that it's not right now production ready. It was, yeah, I guess like a project to figure out if it even works and that if we can really use it and have some workflows running. So that was.
Okay, thank you. We have another question, but I think you already answered it by Martin. Is your Kamailio-based solution working now in the production? So
yeah, it's not. No, definitely. Like there are so many. Again, security topics, again, some redundancy topics, so you don't want your call to drop, right? And stuff like that, so you need to really think of bulletproof solution that you can handle these calls. And in the beginning, we weren't trying to replace the current solution because that would be deadly. And for a couple of people, I don't know, 4 or 5, create this platform on ourselves, and it was not our primarily project. It was we worked on it on I don't know, 2 days, 1 day, a week, in over a year. So it was just a side project. So we weren't even thinking of putting this into production. We just wanted to, again, get the knowledge, see what can work, and yeah, just build a small platform that you can do these kinds of calls and stuff like that.
Okay, we can move on. Did you find any interesting tools for networking management automation with MATLAS CNI? do you plan to outsource any of your achievements?
Oh, interesting. For the network configuration management, I know that this was one architect's like primarily research with the Multas. So I can't really. I mean, we can maybe chat after this presentation on about that. I see that there has to be some sort of automation on the network. Definitely some work has to be done over there, but we weren't, needing it because we had, again, like a different architecture, different deployment, and it would be way easier to, have it on this new upgraded one with Multas, and we would need to sort it out. Yeah, definitely introducing some service concepts and definitely putting more effort into that, but we really didn't. We just focused, on how to easily deploy it on native Kubernetes with, the tools that we had, tested with Kamailio and RTPengine if it really works, and these were our objectives.
And what about second part? Do you plan to outsource any of your achievement?
We were thinking about contributing to the Kamailio, but I think we still need to think about that because, yeah, again, we see that it has flaws, right? So we wouldn't be able to open source this because, again, I think many companies are doing it, especially with the collaboration of the Kamailio company or SIP. I think they're called SIP-wise or SIP capture or something like that. And, they are providing the services on how to set it up, how to do it, and stuff like that. So, us outsourcing it would not make sense. You can directly talk to the people who created it, right? It would be easier to set up, instead of our solution. So, no, it would be primarily in-house. I think there were no discussion on outsourcing it or doing something to it. Yeah.
Okay, the next one. With heavy use of node ports and 32,000 port limit, do you see any kernel changes in IP tables?
Oh yeah, that was one of the issues. I think in terms of the it would become slow. I think that was the performance issue. That if you're adding so much, IPs and stuff like that, it would slow down. We know that you could technically update it yourself somehow. Maybe I know the owner of this question again, but. Yeah, definitely. I think, there is a way. I know that there is even a tool that can help you with the speed and efficiency. Like you could use Redis for caching inside of the Kamailio solution, or you can use HTables that are quite quick in what you want to do. But I know that this was a discussion in the academic paper too about the what's fast or not in connected with the IP tables. Yeah, because if you have a lot of them, it can slow down the performance. So. Yeah, I know about it, but again, it would be redirected to my other colleagues. Sorry for that.
Okay, maybe I can add something. So did you think about NF tables or even BF filter, instead of IP tables?
Yeah, I understand. I think there are options that you can have it implemented. I think we just have the native IP tables again because we weren't scaling to big numbers, so we didn't really care about the performance in that way right now. But definitely, if we had thousands, millions of calls, you would need to figure out, if you opt for something modern instead of ITP tables. Yeah, some virtual. Yeah. So yeah, but in our case, in our project, we that was out of our scope. Yeah, especially with the people that we had. Yeah, it was just.
Okay. You decided to run the RTP engine as deployment. I guess the traffic is UDP. What load balancer do you use? Can a single call session survive a pod outage?
Oh, that's another good point. Yeah. So we were just using, as of now, the native Kubernetes load balancer. Definitely, you can use another RTPengine in front of it as a load balancer. That's possible too. In terms of the daemon sets and deployment, I try to mention, the difference that if you use the daemon set, it's quite limited scaling and stuff like that. If you have deployment, it needs a lot. Plus the redundancy topic. Yeah, that's one of the pinpoints. I think if your pod dies, especially with the media, it's highly not probable that Kamailio would die, but it can happen too. But yeah, this is a topic for redundancy, and yeah, during our research, we figured out that if you have redundant ports from the RTP engines, what you could do, you could cache them so that you would have the sessions IDs, you would have the possibility, I think, to store that, and if there was a failover, you would need to have an operator checking the statuses and stuff like that, and in real time, you wouldn't, you can't wait a minute, oh, something's wrong, right? Call is dropping, right? So there were concepts on how to handle this redundancy. You would run more RTP engines ready, and you would need to have a concept on how to provide that the redirects happen. I think in Kamailio you can do it. You can rewrite the data. You can add to the data more. So like you can have a mechanism on top of it, some process checking if everything is well, if the flows are running, you know, or some parameters in the calls, like you can do that. You can do jitter or some other parameters of the call, like if it's quality one or if it's failing or something like that. So definitely, I think like you can definitely implement that. On the other hand, it might be difficult. Yeah, you will have a trade-off. I think, you know, if you know this fails, you need to have this open. So there may be like a fallback route or something like that created to inform the both parties. Hey, let's switch up to a different pod because it's not working on this port, yeah. So I think it was in the academic paper that I showed you too, yeah, this failover.
Okay, the last question on Slido is, what's the name of the load balancer? We already spoke about it, but maybe, I'm not sure if they ask about the ingress controller or just load balancer, so maybe
so you saw that there was like a load balance in front of it? I don't know, maybe I can
think they ask more about the ingress controller.
Yeah, so we use the Nginx ingress controller.
Yeah. I mean, the Kubernetes ones.
Yeah. So we wanted to just like opt for the native everything. Like we didn't want to really introduce something new. We didn't want to really experiment that much because we, you know, thought that, you know, hey, if this exists, like, why don't we try this, right? So, and then we would figure out, oh, this is bad, this is wrong. Hey, we can do it like that. Or if we're gonna get a something from a vendor, like we know, hey, this can be wrong or something like that, and we can, you know, have some you know, knowledge in that. So yeah, we were using Nginx ingress controller.
Is there any question from the audience?
Then if not, I want to give big thanks to my manager, Yishi Hayek. I think he's in the crowd. The facility for hosting us, for providing this venue. The Cloud Native Product organizers, definitely huge shout out. And major thanks to my team for making this happen, because without them, I wouldn't be presenting here and, you know, creating this solution. So big thanks to them. And here are the references, so like you can, you know, view what I showed you. And thank you all for coming for my presentation. That's it. Thank you guys, and enjoy.
Thank you, Martin.